Next type of reaction that we're going to take a look at is double replacement. To identify a double replacement reaction, you're going to be looking for two ionic compounds as opposed to complex synthesis where you had at least one molecular compound. You can also have acids. Again, acids are really a very special case of an ionic compound. So either of these will give you a double replacement reaction. Okay, and you get the idea of something double with this. So what I have here is looking at the general format of the equation. So each of the letters represents an ion. So what you're going to see with this is that your A is going to switch with your C. And again, notice I have them in blue for boys, so basically it's like a boy and a girl dancing and you switch partners. So the positives are going to switch or the negatives are going to switch. So what you're going to end up with in this is a new compound that is made with C and B. Okay. And a second compound that is A with D. Okay. So to begin, we have calcium, which is your cation, with nitrate, which is your anion, and you have hydrogen as a cation, and chlorine, or chloride, as an anion. So what you're going to see is these two are going to switch places. So it's going to be boy, girl, and when we're done, it'll be boy, girl, or positive, negative, positive, negative. So just like we've been doing with charges before, you can't have two positives and you can't have two negatives, so you have to have one of each. So these two are switching places. So again, this is why it's double replacement, because you have two things that are switching. So what I'm going to end up with is calcium will end up with chlorine, and hydrogen will end up with nitrate. Now that gets us started, but then we need to look at charges. So charge of calcium is +2, chloride is -1, so when I crisscross, I'm going to get CaCl2. When I do charges over here, I'm going to have hydrogen, which is plus, and nitrate, which is minus, so I don't have to do anything with that there, but I am going to balance the equation. So to get two nitrates on this side, I'm going to have to put a 2 in front of HNO3, which is going to give me two hydrogens, which is also going to balance my chlorides. So that is your first double replacement reaction. Another way to look at this is looking at it from a charge perspective. So potassium is a positive, carbonate is a negative, aluminum is a positive, and I'm putting numbers in, and hydroxide's a -1. Really what's important is I always have to end up with a positive with a negative and a positive with a negative. So these guys are switching, so again that's our double replacement. So we are going to end up with potassium with hydroxide. And the important thing is to not bring numbers over unless it's part of a polyatomic ion. So I'm not going to bring the 2 over, I'm just going to bring the K over, and I'm just going to bring the hydroxide over. Then I'm going to look at charge to decide what subscripts I need. So I have +1 and -1, so I really don't need any subscripts for this one. When I go to my second formula, I'm going to be bringing aluminum over, and I'm going to put aluminum with carbonate. Now this time I am bringing the 3, but again that should be part of the polyatomic ion carbonate that you're aware of. And then I'm going to look at charge. So I'm going to have +3 and -2, so I'm going to crisscross and get Al2, CO3, 3. And again, I don't need to worry about anything with the numbers not matching. When I'm writing formulas, I'll balance the equation to take care of that. So we're going to need a 2 in front of the Al to balance the oxygen, or excuse me, the aluminum. I'm going to balance carbonate as a group, and I'm going to put 3 in front of the K2CO3. And again, I chose this formula because this is the most complicated formula in the equation to start with. Okay. This gives me 6 potassiums, so I'm going to put a 6 in front of the KOH, and that also gives me 6 hydroxides, and 2 times 3 is 6 as well. So that is a balanced double replacement reaction. Okay, so you start doing your practice problems on the worksheet. Wanted to just have you focus on this very first part. So we are only looking at writing the complete equation to predict what will occur. Don't worry about the precipitate part. We're going to add that later. Let's just have you focus on writing the formulas. I also did this for you in terms of names because I thought it might be easier for you to just look at it from a name perspective. So what you're going to end up with is switching these two. So barium is going to end up with sulfate, and sodium is going to end up with chloride. And the reason I did it as names first is because that helps you just focus on your formulas. Then you don't have to worry about charges so much and just looking at it from the name. And again, if you don't need to write them as formulas in this activity, it's okay. If you don't, I will tell you on the final exam you will be doing both though. So I'm going to do barium, chloride. Again, barium's +2, chloride's -1. And sodium with sulfate. And that's +1. Sulfate's -2, so I'm going to have Na2SO4. Okay, reacting that to form barium sulfate. So Ba, and then SO4. Okay, and this is +2 and -2, so those are going to cancel out. And then I'm going to add sodium with chloride. So again, you'll always see that there's one positive with one negative, so you'll never have two negatives together in double replacement. You don't have that at any compound, but you do sometimes have what looks like two negatives put together because you have two nonmetals, but this is always a positive and a negative. Again, to balance the equation, I need 2 chlorines, so I'm going to put a 2 in front of NaCl, and that will also give me 2 NAs, which is all what I need to balance the equation. So you can finish the rest of this worksheet. I'm going to go on and show you this worksheet. I want you to focus on writing your formulas on this line. At this point, don't put anything on this second line. We will be revisiting this for another concept, so that line is for a second portion of this. So just finish the equations on this one. So again, we're going to switch sodium and lithium. So you're going to have Na, NO3, plus LiCl, and that's what this is going to look like. And again, all of these are plus and -1, so you don't need to have any subscripts there. So if you'll finish the rest of the examples on this worksheet for practice, and we'll go over the answer key later.